naming Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataon maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan po bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Good day, grade 11 students. Welcome to another learning session in statistics and probability. This is your teacher, Setiel P, your grade 11 math teacher, your guide to an amazing and exciting class today. Now, we're going to discuss quarter 3, lesson number 7, entitled Central Limit Theorem. Before we start the discussion, let us look at our objectives, which are: number 1, illustrate the central limit theorem. Number 2, define sampling distribution of the mean using central limit theorem. And number 3, solve problems involving sampling distribution of the mean. Let us start our discussion by unpacking some words using the activity named Word Scramble. I will give you some statements followed by a jumbled letter, and I will give you 5 seconds to scramble the letters from the word that describes the given statement. Are you ready? Let's start. Number 1. The set contains all the data elements individual or measurement from your experimenting space. These are the letters. 5 seconds. Go! Time's up. If your answer is population, then you are correct. Okay, so let's proceed to statement number 2. It describes the data, population, sample range, and how data is spread in that range. These are the letters. Okay, so 5 seconds. Go! Time's up. If your answer is distribution, then you are correct. Okay, so let's proceed to statement number 3. The average value of all the data from your population or sample. These are the letters. 5 seconds. Go! Time's up. If your answer is mean, then you are correct. Okay, so let's proceed to statement number 4. Number 4, it is randomly selected subset from the population where the sample size is denoted by n. These are the letters. 5 seconds. Go! Time's up. If your answer is sample, then you are correct. Okay, so finally, statement number 5. It is described how spread the population is. These are the letters. 5 seconds. Go! If your answer is standard deviation, then you are correct. Okay, so these are the words that basically we'll use in our entire discussion, together with the concept of normal distribution, and also when the population is not normally distributed. We know that statistics will keep us informed about what is happening in the world, in our world, around us, using the data analysis in our experience in life. This time, let us focus our attention on some cases wherein the population is skewed. Today, we will learn about the concept of central limit theorem. Let us recall we've learned before. Consider the event of throwing a die. Wherein the possible outcomes are 1, 2, 3, 4, 5, and 6. Let us compute the population mean. To compute the population mean, let us use the formula. Mean is equal to the summation of the possible outcome over n. So if we're going to substitute, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 all over 6, which will give us 21 over 6. The result is 3.5. There is another way in solving population mean using its individual probability. We can use the formula mean is equal to the summation of the possible outcome multiplied by the individual probability. So if we're going to substitute, we substitute the formula. We have 1 times 1 over 6 plus 2 times 1 over 6 until 6 times 1 over 6. Then if we're going to simplify, still the result is 3.5. Can you still follow? Okay, so after solving the mean, let us solve the variance. In solving the variance, we need to fill out the two columns, which are x minus the mean, and another column which is the quantity x minus the mean squared. Let us start with the column x minus the mean. So we're going to have 1, which is x, minus the mean, which is 3.5. The result is negative 2.5. Now, let's proceed to 2 minus 3.5. The result is negative 1.5. The pattern continue until 6 minus 3.5 is equal to 2.5. And then the next step is to square each data from the column which is filled out. So if you're going to square out negative 2.5 squared, the result is 6.25. And then if you're going to square negative 1.5 squared, the result is 2.25. The pattern continue until 2.5 squared, the result is 6.25. In order for us to compute the variance, let us use the following formula. So the formula will be variance is equal to the summation of the square of the possible outcome minus the mean and the all over n. So in order for us to get the summation of x minus the mean squared, we're going to get the sum of the last column. So if we're going to get the sum of the last column, the result is 17.5. Now substitute the data. So we have 17.5 over 6. The result is 2.92. So therefore, the variance is 2.92. Here is another way in solving the variance using the probability of each event. So you're going to use the formula variance is equal to the summation of the square of the difference of each outcome and the mean multiplied by each probability respectively. So if you're going to substitute, we'll have quantity 1 minus 3.5 squared multiplied by 1 over 6 plus quantity 2 minus 3.5 squared times 1 over 6 until quantity 6 minus 3.5 squared times 1 over 6. If you're going to compute, the result is still 2.92. Now, this time, let us solve the standard deviation. To solve the standard deviation, let's use the following formula. So, the standard deviation is equal to the square root of the quotient of the summation of each outcome minus the mean over n. So, substituting the given data, so we have the square root of 17.5 over 6. The result is 1.71. So, therefore, the population standard deviation is 1.71. So, the histogram of this experiment will look like this. Okay, now this time, let us consider the possible sample size of 2. So, we have 1, 1, 1, 2, until 6, 6. So, those are the sample. So, if you're going to count, there are 36 sample. So, after that, we're going to solve the sample mean by getting the average between the two sample. So, let's start with the first row. So, 1 plus 1 over 2 or divided by 2 is equal to 1. And next, 1 plus 2 divided by 2, the result is 1.5. So, continue the process until six plus 5 divided by 2, the answer is 5.5. And lastly, 6 plus 6 divided by 2, the answer is 6. After getting the sample mean, let us compute the mean of the sampling distribution of the sample mean. Let us get the summation of all the sample mean, which is equal to 126. Now, substituting in the formula, so we have mean of the sampling distribution is equal to 126 over 36. So, the mean of the sampling distribution is 3.5. Next is, fill out the next two columns. Okay, to fill out the two columns, so we have 1 minus the mean, the result is negative 2.5. And next, you're going to square the negative 2.5, the result is 6.25. And then, 1 minus the mean, 1.5 minus the mean, which is 3.5, the result is negative 2. Squaring negative 2, the result is positive 4. The process continue until okay, 5.5 minus 3.5, which is the mean, the result is 2. If you're going to square, the result is 4. And lastly, we have 6 minus 3.5, the result is 2.5. If you're going to square, the result is 6.25. Then compute for the variance of the sampling distribution of the sample mean. To solve for the variance, we need to get the summation of the data of the last column, okay, which is the result is 52.5. Now, substituting in the formula, so we have variance of the sampling distribution is equal to 52.5 over 36. The result is approximately equal to 1.46. Then lastly, we need to find the standard deviation using the given formula. So the formula will be the square root of, basically the square root of the variance. So we're going to substitute using the given data. So the square root of 52.5 over 36, the result is approximately equal to 1.21. In order for us to construct the histogram of the sampling distribution, we will come up with this table. If we are going to examine the previous data, this table will summarize the data. The sample mean of 1 and 6, the probability is 1 over 36. And the pattern continue until 3.5, which will have the probability of 6 over 36 or 1 over 6. This data will help us in constructing the histogram. So the probability histogram of the sampling distribution of the sample mean will look like this. If you have your notes from our discussion, how will you describe the relation of the population mean and the mean of the sampling distribution? We know that the mean of the population is 3.5, while the mean of the sampling distribution is also 3.5. You're correct. If your answer is the mean of the population is equal to the mean of the sampling distribution, then you are correct. Because the mean of the sampling distribution of the sample mean is equal to the population mean. This time, how will you describe the relation of the population standard deviation and the standard deviation of the sampling distribution? We know that the standard deviation of the population is 1.71, while the standard deviation of the sampling distribution is 1.21. It seems like that the two values are not even related. But let us look further. Remember that the sample size of the sampling distribution is 2. What if we're going to divide the population standard deviation by the square root of the sample size, which is 2? As you can see, we have 1.71 divided by the square root of 2. The result is 1.21. So therefore, the standard deviation of the sampling distribution of the sample mean is equal to the population of the standard deviation divided by the square root of the sample size. Let us go back to the probability histogram. The probability histogram of the population look like this. And the probability histogram of the sampling distribution with size 2 look like this. As we observe, the histogram of the sampling distribution is likely normal compared with the histogram of the population. Based on our observation, we form what we call the central limit theorem. Central limit theorem states that the sampling distribution of the mean approaches a normal distribution as the sample size increases. Regardless of the initial shape of the population distribution, if sample size n are randomly selected from a population, the sampling distribution of the sampling means will approach a normal distribution as the sample size n gets larger. So the formula for the standard deviation will be the standard deviation over square root of n, wherein population standard deviation and sample size. Solving problems in central limit theorem. You're going to use the formula of z, which is equal to the mean minus the population mean all over the population standard deviation divided by the square root of the sample size. So let's have an example. The scores a statistics midterm exam are normally distributed with a mean of 78 and a standard deviation of 6. If the student is selected at random, letter A, what is the probability that his or her score is higher than 90? Letter B, what is the probability that his score is less than 75? And lastly, what is the probability that a class of 30 students will have an average score of less than 75. So let's have the solution. For letter A, or from the given, we have the mean, which is 78, and the standard deviation, which is 6. So the population is normally distributed. So letter A, we're going to get the probability which the score is greater than 90. Solve for Z using the formula equal to the given score minus the mean over the standard deviation. Since we're going to get higher than 90, so we're going to replace x by 90. So 90 minus 78 all over 6. So if you're going to simplify, the answer is 12 over 6, which is equal to 2. Now, using the Z table to determine the required area, so let's look for Z, which is equal to 2. The result is, if we're going to look on the Z table, the answer is 0.4772. So therefore, the probability that his or her is higher than 90 is 0.4772, or in percent form, we're going to have 47.72%. Now let's proceed to letter B. So in letter B, still the given are mean, which is 78, and the standard deviation, which is 6. So still the population is normally distributed. But the question is, the probability wherein the score is less than 75. So using the Z formula, so we have the given score, which is 75, minus the given mean, which is 78, over 6. So the result is negative 3 over 6. So if we're going to simplify, the result is negative 5, negative 0.5. Using the Z table again to determine the required area, you're going to look for negative 0. So the answer is 0.3085. So therefore, the probability that his or her score is less than 75 is 0.3085, or in percent form, that is 30.85%. Now lastly, in letter C, if you go back to the problem is, what is the probability that a class of 30 students will have an average score of less than 75? So this time, you're going to use the central limit theorem. So the solution will be, so we're going to state the given again. The given are the mean, which is 78, the standard deviation, which is 6, and the n is 30. So we're going to get the probability of the average score, or the mean, is less than 75. So using the Z formula, we'll have the mean, which is 75, minus the given population mean, which is 78, all over 6 divided by the square root of 30, which is the given number of students. If you're going to simplify using your calculator, the result is negative 2.74. Now, using the Z table to determine the required area, which is negative 2.74, the result is 0.0031. So therefore, the probability that the sample will have a mean of less than 75 is 0.0031, or 0.31%. Now this time, we're going to have this generalization, which is an activity, fill in the blank. Okay, so I will give you 5 seconds again to fill out those blanks based on our discussion. So let's have number 1. Supply the missing word. Number 1, central limit theorem states that the sampling distribution of the mean approaches blank as the sample size increases. 5 seconds, go! The answer is normal distribution. So therefore, again, central limit theorem states that the sampling distribution of the mean approaches a normal distribution as the sample size increases. Okay, can you still follow? Okay, let's proceed to number 2. A good estimate of the mean is obtained if the standard error of the mean is blank. 5 seconds. Go. Time's up. The answer is close to 0. So, a good estimate of the mean is obtained if the standard error of the mean is close to 0. Next, number 3. The mean is a poor estimate if the standard error of the mean is blank. Again, the mean is a poor estimate if the standard error of the mean is blank. 5 seconds. Go. Time's up. The answer is larger. So again, the mean is a poor estimate if the standard error of the mean is larger. Okay, next, number 4. The mean of the sampling distribution of the sample means is blank to the population mean. Again, the mean of the sampling distribution of the sample means is blank to the population mean. 5 seconds. Go. Time's up. The answer is equal. So the mean of the sampling distribution of the sample means is equal to the population mean. Number 5. The blank and blank measures the degree of accuracy of the sample mean as estimated as an estimate of the population mean. Again, the blank measures the degree of accuracy of the sample mean as an estimate or as an estimate of the population mean. 5 seconds. Go. Time's up. The answer is standard error of the mean. Okay. So this time, we're going to cater some questions from our discussion. You can throw your questions using the comment box. Okay, so I think we don't have any question from our viewers. Okay, so let's have our to-do activity. Kindly answer the assessment portion on your module in week number 7, which will have the lesson Central Limit Theorem. This is our takeaway math quotation. Math is not a problem to be solved, but a number to be enjoyed. Okay, thank you for watching. This has been your mathematics teacher. I'm Mr. Setiel P from Malinta Senior High School saying God bless and happy learning.